Hello, this is Mr. Stansbury. I'm going to take you through the 9K assignment. Okay, so we're going to start here with number 1. Find the coordinates of the points of intersection with the graphs of y equals this and y equals that. So if you are looking for the point of intersection, what we need to do is we need to figure out when these two equations have the exact same points. So I want to know when these two equal each other. So the nice part about this is, look, you've got y equals x plus 6. I'm going to substitute this x plus 6 in place of this y, because I know that wherever I see a y, it's the same thing as x plus 6. So I'm going to do x plus 6 equals x squared minus 2x plus 8. Okay, and then now I'm going to bring it all to one side or the other. So I'm going to subtract my x and my 6. And I'm going to set this left side over here equal to 0. And we got x squared minus 3x plus 2. And then hopefully this over here will factor, and this one does happen to factor because the factors of 2 that add up to 3 are 2 and 1, and since it has to add up to negative 3, this has to be negative 2 and negative 1. So that means x has to equal 2, and then x also has to equal 1. That either 2 or 1 will make this work. So what that means is we don't have just a point of intersection, we have a point. We have points of intersection. Okay, so we have 2. So that means one of the points is going to be at 2 something, and then the other point is going to be at 1 something. So we have to figure out what both of those are. So to figure out what the y is, we plug the x into either this equation or that equation here. I'm going to choose this one because that one looks a little nicer. It's just y equals x minus 6, or sorry, x plus 6. So in this case, we got y equals 2 plus 6. Which gives us 8. So one of the intersection points is at 2, 8, and then the other one is going to be at y equals 1 plus 6. So that's going to be at 7. So the 2 points of intersection are going to be at 2, 8 and 1, 7. Okay? Because if you, just to kind of help understand this thing here, we have this equation x squared minus 2x plus 8. It's some kind of parabola-y looking thing like so. And then this is a straight line. So we got a straight line. So we're going to have 1, 2 points of intersection. Okay, that's not necessarily where it's going to be at. Well, it's actually going to be at 2, 8 and at 1, 7. But so that's roughly, that's just to kind of give you an idea why there's 2 points instead of just 1 like we're normally used to seeing. Okay, B. We're going to do the same thing. This 2x minus 3, I'm going to plug that in for this y right here. So we got 2x minus 3 equals negative x squared plus 3x plus 9. Okay. Now, we can either move both of these over to the right-hand side, or since the x squared is negative, we could move everything to the left-hand side. It really doesn't matter. I'm just going to stick with what we've done before. So I'm going to just do subtract 2x and add 3. So I'm going to subtract 2x and add 3 here. And we get 0 equals negative x squared plus x plus 12. Right? Now, I don't like that negative x squared. So what I'm going to do is I'm just going to change all the signs. So I'm going to multiply everything by negative 1, which will give me 0, which basically just means switch all the signs. X squared minus x minus 12. Okay? So then we got to try to see if this here will factor. Factors of 12 that have a difference of 1. 1 times 12 doesn't work. 2 times 6 doesn't work. But 3 times 4 does work. So we got 3 and 4. We know that these two numbers here have to add up to negative 1. So it's going to have to be negative 4 plus 3. Okay? So x has to equal negative 3. And then x can also equal positive 4. So again, we're going to have two different solutions. One's going to be negative 3 for the x, and one's going to be 4 for the x. And now we have to find both of the y's. So y equals 2 times x, which in this case is negative 3, minus 3. Just using this one right here. So we get y 2 times negative 3 is negative 6, and negative 3 gives us negative 9. So one intersection points at negative 3, negative 9. And the other one's going to be y equals 2 times 4 minus 3. So that's going to be 8 minus 3. So that y value is going to be 5. Okay, so then there's our two intersection points. Okay? Okay. Next one. Number 1, find the coordinates of the points of intersections of these graphs. So now we're doing C and D here. So I'm going to plug this 2x minus 6 in for that y there. So we get 2x minus 6 equals x squared minus 4x plus 3. Okay. So I'm going to subtract the 2x and add the 6. And we get 0 over here equals x squared minus 6x plus 9. Okay. So let's see if we can factor this out here. Factors of 9, which are 1 and 9, and 3 and 3, that add up to 6. It's going to be 3 and 3. So we got x and x, 3 and 3. They have to add up to negative 6, so that's going to have to be negative 3 and negative 3. So x has to equal 3 for this one, and it's also 3 for that one. So there's only going to be one point of intersection. Okay? And so let's find that one, and then we'll talk about what this should look like. So if the x value is going to be 3, we've got to figure out what the y is. So let's use this equation here. So we got y equals 2 times x, which we now know is 3, minus 6. So y equals 2 times 3 is 6 minus 6. The y coordinate is 0. So really what this means here, if we're going to graph it, which we don't have to, is that this graph here is going to look something like this. And then our equation, the other one's going to look like that. So it's only going to intersect right there at one point. Okay, so that's what, since it's a parabola and a straight line, so it's just going to hit just down at one little spot there. Okay, okay, let's try D. Plug the x minus 3 in for this y here. So we get x minus 3 equals x squared minus 3x plus 2. So I'm going to subtract x and add 3. Okay, so we get 0 equals x squared minus 4x plus 5. Okay, so then now we try to factor that. Factors of 5 that add up to 4, there aren't any. So what we'd have to try to do then, since it's not going to factor and give us nice points, what we should do is try to plug this into the quadratic equation and see what happens. Okay, so it's x equals, quadratic is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so in this case here, a is 1, b is negative 4, and c is 5. So let's see what we get with that. X equals negative 4 plus or minus negative 4 in parentheses squared minus 4 times 1 times 5 all over 2 times 1. Okay, so we get x equals 4 plus or minus negative 4 squared is 16. Negative 4 times 1 times 5 is negative 20 all over 2. And so then we get x equals negative 4 plus or minus the square root of negative 4 over 2. Now, this here, this negative here, produces a problem, right? We can't take the square root of a negative number. So, since it's a square root of a negative number, this means that there are no intersection points. Okay, so that means that these two graphs here, so let's say here's our parabola and then here's our line here, they're not going to intersect at all. Okay? Okay. Let's take a look at the next one, number 1. Find the coordinates of the points of intersection of the graphs with these equations here. So let's put this 5x minus 4 in here. So we got 5x minus 4 equals negative x squared plus 4x minus 7. So subtract 5x and add 4. And we get 0 equals negative x squared minus x minus 3, right? So let's switch all the signs here. So we get 0 equals x squared plus x plus 3. What are the factors of 3 that add up to 1? There are none, so that's not going to work. So then what we'd want to do is let's plug this thing into the quadratic, right? So we get a is 1, b is 1, c is 3. Okay. Now, we can keep plugging this into the quadratic, or actually, you could actually graph these and find the intersection points. Okay, but for now, we're going to just plug it into the quadratic, and then on the next one, we're gonna I'm going to show you how to do this with the graphing calculator or Desmos. Okay, so quadratic. So we got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, we get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 3 all over 2 times 1. Okay, so we get x equals negative 1 plus or minus. We get 1 minus 12 all over 2. So we get x equals negative 1 plus or minus square root of negative 11 over 2. Again, that's a problem. We can't take the square root of a negative number unless we're talking about imaginary numbers, which we're not. So that means that this has no points of intersection. Okay, these two graphs are not going to cross. Okay, last one, f. 3x minus 7, we're going to plug that in here. So we get y equals, sorry, not y equals, but 3x minus 7 equals x squared minus 5x plus 9. I'm going to subtract my 3x and add my 7. And we get 0 equals x squared minus 8x plus 16. Okay, so let's see if this will factor. X and x. Factors of 16 that add up to 8 are going to be 4 and 4. And since they have to add up to negative 8, it's going to be negative 4 and negative 4. So x has to equal 4 and 4. So it's the same one. So that means it's just going to touch at one spot. Okay, so our intersection is going to be at 4 something. So let's just plug it in. So we got y equals 3x minus 7. So it's 3 times 4 minus 7. Y equals 12 minus 7. So the y coordinate is going to be 5. And it just touches at one spot. Okay? Okay. Next one here. Use a graphing calculator or some kind of website. I will show you... I'll show you both. Okay, first one I'm going to show you with Desmos, and the second one I'll show you with a graphing calculator. Okay. Okay, so let's use Desmos first to graph those two and find the intersection point. Okay, so we'll bring up Desmos.com, take you straight into the calculator, and so now what we're going to want to do is we're going to want to graph these two things. So now you just type in x. And then to do squared, you got to push the up arrow, which is shift 6. So that's x to the second. And then now I want to push to the right arrow, which will take me back down into the regular, take me out of the power and back into the normal number here. So then minus 3x plus 7. Okay, so there's one graph. Okay, now I'm going to add in a new graph. And that new graph is going to be x plus 5. So we got x plus 5. And it's kind of nice because it actually gives us two different colors here. Okay. So then to find where it intersects, the nice part about this here is you just put your cursor over the top of that point there and it'll tell you exactly where it intersects. So point 586. Okay. So this one here is 0.586, and the other one was 5.586. 6. So that's one intersection point. Okay, right? 0.586 and 5.586, and then the other point is going to be 3.414 and 8.414. So we got 3.414 and 8.414 is the other coordinate. Okay, so those are the two intersection points. Okay, now B, I'm going to actually show you on the graphing calculator so that you can use both of these. Honestly, Desmos is probably easier, but you're probably going to have more, you'll have access to the graphing calculator a little bit better. Okay, so let's do both. So on this one, graphing calculator, push y equals, clear, and then now we're just going to enter in these two functions. So we're going to do x squared minus 5x plus 2 for one, and then for the other one we're going to do x minus 7. X minus 7. And then for the first time, we shouldn't have to do this every time, but just the first one we'll do zoom standard, and then it will graph these two, and hopefully it'll show up on the screen. And there it is, showing up just right here. It looks like just one point down here. So then what we do is we do, on the graphing calculator, you do second, and you can hit the trace button because that's the calculate. So we're going to calculate, and we want to calculate where they intersect. So we'll go down here to 5 and do intersect. Okay, and this is going to come in really handy for those taking who are going to end up taking studies 2, learning how to do this, because we're going to use this idea here a lot next year. Okay, so first curve. So what they're asking you, you want to know the intersection between this curve. Is this one of the curves you want to find the intersection of? It's like yes, so we'll push enter. And then the second curve is this one. Yep, I want to find the intersection of that one, and I push enter. And it will tell me that one of my intersection points here, if it has one, there it is at 2.99999, which really means 3 and -4. Okay, is one intersection point, and then it's really kind of hard to tell. It looks like that's the only intersection point. So I'm going to show you this really cool trick here, and we're going to do zoom, and then I think we go down here farther, and we can do zoom. Oh, it's the zoom box. That's what I wanted, which was, oh, it was the first one we had right there. So zoom box. If I push enter, then what I can do is I can use these arrows to just zoom in on what I want to put. So if I'm going to put that in my lower left corner, I just push enter, and then I'm going to push up, and I'm going to push over. Okay, and it's going to zoom in. My whole screen is going to zoom in just on that point right there. So then we can, that part of the graph right there. So now we should be able to look at it and see, and it does look like there's just one intersection point down here. Okay, it doesn't look like it hits 2. Let's just double check just in case. Second, calculate, intersect. I'm just going to go a little bit farther out here just to make sure it doesn't intersect somewhere else. I'll push first curve, yep. Is this the second curve you want to find the intersection of? Yep. You want us to guess? Sure. Push equals one more time, and it's calculating. It's at 3 and -4, which we already got. So that's the only intersection point. Okay? Okay. So what we're going to do now is do C, and on that one I'm going to go back to Desmos. So this one was, first one was Desmos. This was the TI. This one I'm going to do with Desmos, and this one I'm going to do with TI. Okay? Just to kind of give you an idea for both. So this one here, it's nice. Just push X's on those. So we just close those two out, and now we're going to enter these in. So we're going to do -X, and then again it's got to be squared, so you got to push Shift 6, which is the up arrow, squared, and then push the arrow to the right arrow. Lost it. Push the arrow to the right, and it takes you out of the power. And now we can do plus 4x minus 2. So there's 1. And the really cool thing about this, look, it gives you the vertex, it gives you the x-intercepts, it gives you the y-intercepts. This is really a pretty cool program here. So next thing we want to do is push in our, oops, I put the wrong function in there. Let's try this again. So we got x squared. Oh, it's negative x squared. And then we got minus 2x. I was doing the bottom one. Minus 2x, and then plus 4. And then on this one, we're going to put x plus 8. Okay, and then we can pretty plainly see from these right here that they do not intersect at all. So we do no points of intersection. Okay. All right. Back to the TI. Let's try that one again. We already cleared those out, so we're going to put these in here. So now, when you have a negative x squared, make sure you don't put subtract. You're going to push the negative. It changes it. If you do push subtract in there, it's going to give you an error. So push negative x squared plus 4x minus 2. And then on the next one down, we get 5x minus 6. Okay, and then let's do zoom. Let's go back to zoom standard again, because we did do that little zoom box thing. Okay, so there's the two graphs, and it definitely looks like it intersects here, and it's going to intersect down here, which we can't see. So let's do this. Let's find this one here first. So we'll do second, calculate, and we're going to do the intersection. And we want to get this up somewhere in the neighborhood of where these two intersect. So I'm actually going to go a little bit past it. And it says, is this the first curve? Yep. And it's going to jump to the other one. Is this the other line you want to find the intersection of? Yep. You want us to guess? Sure, if you want to call it that. 1.561. We're really supposed to do this only to two decimal places. So 1.56 and 1.81. 1.56 and 1.81 is one of them. And there is another one on here that we can't see. It's out of the window here. So I'm going to show you this. This window here, the x minimum and the x minimum and the x maximum, we got negative 10 to 10 and then positive 10. Sorry, negative 10 to positive 10 on the y. So what that means is this is negative 10, that's positive 10. This is negative 10, sorry, that's positive 10, and this is negative 10. We need to go down farther. So instead of the y being negative 10, we need to make that bigger. So our y minimum, instead of negative 10, I'm going to put maybe negative 30 just to make sure that we can get that thing in there. And then it'll show there's that graph, and then it'll show the other graph. And then look, now we can see our point of intersection there. So then we'll do second, calculate, intersect, and now this intersection here has to be closer to that one. If we leave it up here, it's going to give us that intersection that we already found. So we got to get down closer to this one. Push enter for the first curve, enter for the second curve. Do you want us to guess? Yes. And we get the intersection is negative 2.56. And the y is negative 18.81. Okay, so those are our 2 points of intersection. Okay, that's all there is for this 9K assignment. If you have any other questions, please feel free to ask in class. Thanks.